All right, bisectors of triangles today. Bisectors of triangles today. And the first term we're going to discuss, a perpendicular bisector. Of a segment. Divides the segment into two congruent pieces and intersects the segment at 90 degrees. A perpendicular bisector does just what its name suggests. If you have a segment and another segment is its perpendicular bisector, if AB is the perpendicular bisector of CD, then it intersects it at 90 degrees and it splits it in half. And the perpendicular bisector can be of a segment or it can be of a side of a triangle. Now, a couple really important rules regarding perpendicular bisectors. If a point is on the perpendicular bisector, I'm going to use this symbol for perpendicular bisector. If a point is on a perpendicular bisector, then it is equidistant from the endpoints of the segment. If a point is on a perpendicular bisector, then it is equidistant. Equidistant means equal distance from the endpoints of the segment. Now I'll let you get that wrote down and then I'm going to see if it sinks in any. If a point is on a perpendicular bisector, then it is equal distance from the endpoints of the segment. So what can we say about AC, segment AC? It's not drawn, doesn't need to be drawn. We can draw it if you need to picture it. And segment AD. Based on this rule we just wrote down, what can you say about those two segments? Let me read this again. If a point is on a perpendicular bisector, is AB a perpendicular bisector of CD? Yes, it is. If a point is on a perpendicular bisector, is A on a perpendicular bisector? See it?
Yes.
A is on a perpendicular bisector. What does the rule say? It's equal distance from the endpoints. Isn't C an endpoint? And D is an endpoint, right? So what do you know about AC and AD? They're congruent. Very good. These two are congruent. What can you say about BC and BD? What do you know about BC, the distance from B to C, and the distance from B to D? They are congruent. Because B is on the perpendicular bisector, isn't it? Let's try this. We'll go with purple. Doesn't really look it. How about point E? What can we say about EC and ED? Somebody said they're congruent. Why are they congruent? Why is this segment congruent to this segment? Speak up. They're the same distance from each other. And why are they the same distance from each other? We try to help. Isn't the reason that they're congruent is because E is a point on a perpendicular bisector? If E is sitting on a perpendicular bisector, then it's going to be the same distance from the end points of the segment. Okay? The converse of that is also true. If a point is equidistant from the endpoints of a segment, then it is on a perpendicular bisector. All right, that's the converse of the original theorem. Here's how this rule would work. If you're given this diagram and this diagram, and you're told that AD is congruent to AE, Let's add a number right here. Let's make this 8. If AD is congruent to AE, find the measure of angle, ACD, and the length of segment, CE. A is equal distance, or AD. That distance is congruent to AE. That makes A equidistant from the endpoints of a segment, doesn't it? What do we know about angle ACD? It's a right angle, isn't it? Makes this a right angle. What does it make? What's the name of the segment AB called now? What's it called? It's called a perpendicular bisector. Very good. Very good. If it's on it, if A is the same distance from D as it is from E, then it's on a perpendicular bisector, which makes that angle 90 degrees. So how far is it from C to E? 8. Very good. All right. Does that make any sense to you guys? All right, let's get this in your notes. The perpendicular bisectors of a triangle intersect at a point called the circumcenter. And let's say this. The perpendicular bisectors of a triangle intersect at a point called the circumcenter, which is equidistant from the vertices of the triangle. So here's what a diagram of that would look like. If we get a triangle, triangle ABC. Triangle ABC has 3 sides. So how many perpendicular bisectors will it have?
3.
It'll have 3. Very good. So there's going to be a bisector that bisects side AC at point D. There's going to be a perpendicular bisector for side BC. That's right here around F. And there's a perpendicular bisector for side AC, and we're going to call it point E. Now I'm going to try to be as accurate as I can here. Okay, we're going to call this point right here, point P. Now, if side AC has a perpendicular bisector, it would look like this, wouldn't it? It would intersect this side at 90, and it would split it in half. The perpendicular bisector of side CB would intersect it at 90 degrees and split it in half. The perpendicular bisector for side AB would intersect it at 90 and split it in half. Everybody see these three perpendicular bisectors of a triangle? Now, I stopped them at point P, and I also stopped them at the side of the triangle just so that the picture won't get too confusing. But they don't have to stop. They can go on forever in both directions. But that's what they do. They intersect. There's a segment that intersects with each side of a triangle that splits it in half and creates a 90-degree angle. Now, what did the rule just say? The perpendicular bisectors of a triangle intersect at a point called the circumcenter. Point P is the circumcenter, which is equidistant from the vertices of the triangle. So if we took a line now, or a segment, and connected it from the vertex, each vertex of the triangle, to the circumcenter, we're going to be going, I'm going to do them in a little, let me see this line right here, and this line, and this line. Those lines all represent the distance from the circumcenter to the vertex of the triangle, agreed? Those are all congruent, all right? AP is congruent to BP, which is congruent to CP. Now, this is really hard to do, but I'm going to try it anyway because this is my favorite class. Well, this class and third block, these are my two favorite classes. Since P is the same distance from each vertex, what else do you know about a point that's the same distance from the sides of something? What's that point called? Anybody? A point that's the same distance from the sides of something. Midpoint, that's good. What else? I'm thinking in terms of a shape that's more round. A point that's the same distance from the sides of something. Say it again. Closer. Well, the radius isn't the same distance from the sides of something. What is the same distance from the sides of something? What's it called?
Diameter?
No, not the diameter. If you were standing somewhere and you were the same distance from everybody, what shape would they be in?
A line.
Well, they would be in a circle, wouldn't they? And what would you be? You would be the center. Okay? So think of the term circumcenter. Circumcenter. P is the circumcenter. P is the center of a circle that could be drawn around this triangle. Okay? Circumcenter, like the term circumscribe. So this is hard to draw. This is hard to draw. There's a circle that goes around this triangle. Okay? There's a circle that goes around every triangle. There's a circle that's circumscribed about a triangle. Every triangle has a circumcenter that is equidistant from the vertices of the triangle. That circumcenter is the center of a circle that is circumscribed about a triangle. Got that? Write that down. We're going to say, here's the symbol for circle. Circle P. When you're referring to a circle, you use the name of the point that's the center of the circle as your reference. So this is circle P. The green circle is circle P. Circle P is circumscribed about triangle ABC. Circle P is circumscribed about triangle ABC. All right, so we good with that? A lot of information going on with perpendicular bisectors. They meet at the circumcenter. They create a 90-degree angle with every side of a triangle, and they split it in half. Where they meet at the circumcenter is the same distance from every vertex in a triangle, which is also the center of a circle that can be drawn around that same triangle. All right? All right, very good. So let's move along now. We're going to talk about angle bisectors. And we're going to say this right here. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So here's a picture. Let's get an angle. got angle ABC. And now we're going to bisect this angle. We're going to get a ray that starts at point B, and it's going to split this angle in half. I'm going to put point D on it. So if angle ABD is congruent to angle DBC, then ray BD is an angle bisector, isn't it? It divides the angle into two equal pieces, or into two congruent angles. If a point is on the bisector of an angle, then it is equal distance from the sides of the angle. So, do you see this distance right here from A to C and from A to D? Those are congruent to each other when they're drawn at a 90-degree angle. Okay? And let's write that down as well, that when determining the distance from a point to a line, when determining the distance from a point to a line, it must be along a perpendicular. Perpendicular. All right, if we were measuring the distance from D to C, that segment's got to be perpendicular to C. And if we were measuring the distance from A to D, then that distance has to be perpendicular to, or that line has to be perpendicular to AB. All right? If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. Then we need the converse of that. If a point is equidistant from the sides of an angle, then it is on the angle bisector. If a point is equidistant from the sides of an angle. So it goes back to, if you have an angle, all right, we got angle ABC again. We got ray BD. If you're told that there's a point E sitting on this ray, and you're told that that distance is the same as this distance, if those two distances are the same from E to A, and from E to C, And then this angle here is 30 degrees. What is the measure of angle ABE? Okay, that would be 30 degrees. And this refers to angles and angles in a triangle. So what it boils down to is, if you're told that an angle is divided into two congruent pieces or two congruent angles, then any point on that bisector is the same distance from the sides. If a point is the same distance from the sides of an angle, then the line that it's on bisects the angle. So these two angles are congruent. All right, and then one more thing we got to know about the angle bisectors of a triangle. All right. The angle bisectors of a triangle. Intersect at a point called the incenter. Which is equal distance or equidistant from the sides of a triangle. Incenter, equal distance from the sides of a triangle. So if you had triangle ABC again, triangle ABC, how many angle bisectors does a triangle have? 3, because it's got 3 angles, right? 3 angle bisectors. So look, if we take an angle bisector and we draw it out of angle A, kind of here. And if we take an angle bisector and we draw it out of angle C, kind of be there. And then an angle bisector out of angle B, it would kind of be there. And these two angles would be congruent. These two angles would be congruent. And these two angles would be congruent. The angle bisectors of a triangle intersect at a point called the incenter. So point this right here. I'm going to call it D. Point D is the incenter of triangle ABC. Point D is the incenter of triangle ABC. And let's do this, just add to this right here. And equidistant from the sides of the triangle. Point D is the incenter. Every triangle has an incenter. This incenter is now the center of a circle that can be drawn inside of the triangle. Okay? So now there's a circle we can draw inside this triangle. Oh boy. Point D is the center of that circle. That's why point D is the same distance from the sides of this circle. Okay? D is the same distance from the sides of the triangle because it's the center of the circle. A lot of information today. Any questions on what we've covered? Perpendicular bisectors and angle bisectors, their point of intersection, and how it relates to their respective triangles. All right, so I'm going to give you a little bit of practice to do today. A lot of you guys aren't checking focus for homework like I asked you to, and unfortunately, it's going to start reflecting your grade. Your practice for today is on page 59, 1 through 12, and then page 60, 1 through 10. When you've completed that and you've got your notes in front of you, check focus for homework. Check focus for homework. That means that's something that should be completed tonight or tomorrow morning before you get to class. I was looking through focus yesterday, and the homework assignment that I posted, about 3 people did it. So that's pretty unacceptable. Need to be more timely. Your assignments are, you're supposed to check focus each day, guys. All right, you're supposed to complete the assignment that I give that day, check focus that afternoon or that evening, and get your work finished and submitted. Anybody in class have any questions? Anybody in the Zoom meeting have any questions?
Nope.
No.
Okay, again, you guys that aren't using your first and last name for your Zoom profile, you will not be admitted after today to any meetings. So please get that taken care of. Other than that, I need you, there won't be a Zoom meeting Thursday or Friday. Your notes and work for Monday will be on YouTube and or our Focus webpage. Our next Zoom meeting will be next Wednesday.
Okay.
All right, go ahead and check out and have a good weekend.
Thank you.
Wait, so we have a meeting tomorrow?
No, I won't be here tomorrow.
Okay, well, I'm Lucas and I'm leaving.
Thank you.
I'm Jason and I'm leaving.
All right.
I'm Andres and I'm leaving.
Thank you, sir.
See you next week.
All right, buddy.